requirement that fire pump supply conductors must be kept entirely independent of all other wiring is in place to guarantee the reliable and uninterrupted operation of the fire pump during a fire. This independence minimizes the risk of electrical faults, mechanical damage, or other issues affecting the fire pump's power supply. While wrapping the conductors with fire wrap, specifically a material meeting Underwriters Laboratories Standard 1724, offers that degree of thermal protection, it doesn't fully satisfy the code's intent for complete independence. The concern lies in the potential for collateral damage or interference from other cables within the manhole, particularly during a significant fire event. The heat generated could still affect the fire-wrapped conductors, potentially compromising their insulation or causing them to fail. Furthermore, the physical proximity to other cables introduces the risk of mechanical damage during maintenance or in the event of a cable failure. Claiming independence solely based on fire wrapping is generally not recommended. The preferred approach is to adhere strictly to the code's requirement for complete separation. This may involve rerouting the fire pump supply conductors to avoid the manhole altogether, or employing an alternative method for traversing the obstacle. For example, a dedicated, fire-rated duct bank could be installed beneath the manhole, ensuring physical separation from other utilities. If complete separation is not feasible due to site constraints or other factors, several alternative strategies can be considered. Firstly, a redundant fire pump system can be installed. This provides a backup fire pump that can automatically activate if the primary pump fails, ensuring continuous fire protection. The redundant pump should have its own independent power supply, also separated from other wiring. Secondly, an alternative power source, such as an emergency generator or an uninterruptible power supply, UPS, can be provided specifically for the fire pump. This ensures that the pump can operate even if the main power supply is interrupted. Thirdly, enhanced physical protection measures can be implemented within the manhole. This could involve encasing the fire pump supply conductors in a rigid, fire-rated conduit system and providing additional fire barriers between the fire pump conductors and other cables. However, these measures should be carefully evaluated to ensure that they provide an adequate level of protection and do not compromise the overall safety and reliability of the electrical system. It's crucial to consult with a qualified electrical engineer and the authority having jurisdiction to determine the most appropriate solution for a given situation. The AHA has the final say in interpreting and enforcing the code requirements. When evaluating different options, consider the following factors. 1. The severity of the potential fire hazard. 2. The reliability of the fire pump system. 3. The cost of the different solutions. 4. The ease of maintenance and inspection. 5. The long-term performance and durability of the chosen solution. Ensure that all materials and installation methods comply with applicable codes and standards, including the National Electrical Code, NEC, and local building codes. Proper documentation and labeling of the fire pump supply conductors are also essential. Clearly identify the conductors as serving the fire pump and indicate the voltage, amperage, and other relevant information. This helps to prevent accidental disconnection or damage during maintenance or emergency situations. Regular inspection and testing of the fire pump system are crucial to ensure its continued reliability. This should include testing the operation of the fire pump, the performance of the power supply system, and the integrity of the wiring and connections. Any deficiencies or issues should be promptly addressed. Specific NEC articles relevant to fire pump installations include Article 695, which covers fire pumps, and Article 700, which covers emergency systems. These articles provide detailed requirements for the design, installation, and maintenance of fire pump systems, including the separation of fire pump supply conductors. Other relevant NEC articles may include those pertaining to wiring methods, overcurrent protection, and grounding. The NEC Handbook provides additional guidance and explanations of the code requirements. It includes diagrams, examples, and other helpful information to aid in understanding and applying the code. However, it is important to note that the NEC Handbook is not itself a code and should not be used as a substitute for the actual code requirements. When installing fire pump wiring, it's essential to follow all applicable safety precautions. This includes energizing the power supply before working on any electrical equipment, using appropriate personal protective equipment (PPE), and following safe work practices. Electrical work should only be performed by qualified and licensed electricians. Remember that the primary goal is to ensure that the fire pump can operate reliably and without interruption in the event of a fire. Any compromises or shortcuts in the installation of the fire pump wiring could have serious consequences. Therefore, it is important to take the time to do the job right and to follow all applicable codes and standards. Let's delve deeper into the technical aspects of maintaining the required independence of fire pump supply conductors. The concept of entirely independent implies a complete physical and electrical separation from all other non-fire pump related wiring. This means that the fire pump conductor should not share the same raceway, cable tray, junction box, or other enclosure with any other wiring systems. The conductors should also be routed in a manner that minimizes the risk of physical damage or interference from other equipment or activities. In practical terms, achieving complete independence can be challenging, especially in existing buildings or congested areas. However, there are several strategies that can be employed to minimize the risks and ensure compliance with the code. Firstly, consider using dedicated raceways or conduits for the fire pump supply conductors. These raceways should be clearly labeled and identified as serving the fire pump only. The raceway should be installed in a manner that protects the conductors from physical damage, such as being buried underground or installed in a protected location. Secondly, maintain adequate separation between the fire pump supply conductors and other wiring systems. This can be achieved by using physical barriers, such as fire-rated walls or partitions, or by routing the conductors in separate areas of the building. The separation distance should be sufficient to prevent the spread of fire or other hazards from one wiring system to another. Thirdly, avoid using common grounding or bonding conductors for the fire pump supply conductors and other wiring systems. The fire pump system should have its own dedicated grounding electrode system, which is separate from the grounding system for the rest of the building. This helps to minimize the risk of ground faults or other electrical problems that could affect the operation of the fire pump. Fourthly, carefully select the appropriate wiring method for the fire pump supply conductors. The wiring method should be suitable for the environment in which it is installed and should be able to withstand the anticipated mechanical stresses and environmental conditions. For example, rigid metal conduit (RMC) is often used for fire pump wiring because it provides excellent protection against physical damage and fire. Fifthly, ensure that all connections and terminations are properly made and secured. Loose or corroded connections can cause overheating and electrical failures, which could jeopardize the operation of the fire pump. Use appropriate connectors and terminals that are listed for use with the type of conductor being used. Sixthly, implement a comprehensive testing and maintenance program for the fire pump system. This program should include regular inspections of the wiring and connections, as well as periodic testing of the fire pump's performance. Any deficiencies or problems should be promptly addressed. When fire wrapping conductors, ensure that the material used is specifically listed and labeled for electrical conductor fire protection, meeting UL 1724 standards. The application must be according to the manufacturer's instructions to achieve the stated fire resistance rating. The fire wrap alone does not make the cable independent, it only adds a degree of fire protection. However, it is important to consider that fire wrapping will add to the overall conductor and capacity rating, which must be considered in the system design. The type of fire wrap is determined by the required fire rating. Consult the manufacturer's documentation to confirm compliance with applicable building codes. It is also important to inspect the fire wrap on a regular basis to ensure that it has not been damaged or compromised. Any damage should be repaired immediately. It is also imperative that the fire pump controller is listed for fire pump service and installed according to the manufacturer's instructions. The controller must be located in a fire-rated room or enclosure that is protected from physical damage. Also make sure to use the correct overcurrent protection. Size the overcurrent protection device according to NEC Article 430.52 or 695.5, which permit sizing up to the locked rotor amps of the fire pump motor. Voltage drop calculations are crucial for fire pump circuits. Excessive voltage drop can reduce the motor's torque, affecting the pump's performance. Maintain voltage drop within NEC recommendations for fire pump applications, typically no more than 15% during motor starting and 5% during full load operation. Coordination studies should be performed to ensure that protective devices will operate selectively, so a fault on a branch circuit will not trip the main breaker feeding the fire pump. Review the authority having jurisdiction requirements for fire pump installations. The AHJ may have additional requirements beyond the NEC, such as local amendments or specific interpretations of the code. Always consult with a qualified electrical engineer to ensure that the fire pump installation meets all applicable codes and standards. The design and installation of fire pump systems can be complex, and it is important to have the expertise of a professional to ensure that the system is safe and reliable. They can assist in the selection of appropriate equipment, the design of the wiring system, and the implementation of a comprehensive testing and maintenance program. Remember, the goal is to ensure the fire pump functions when needed.